Ah, Hello everybody, welcome back to the channel. So we have brought a very nice question from class 11th NCERT book, which is related with work, energy and power, and talking about the examples of NCERT, they never disappoint. So it's a very interesting question. It's about a nuclear reactor. We know that in a nuclear reactor, the neutrons must be slowed down to attain a controlled fission reaction. And to slow down the neutrons, we use moderators. What is moderator? Moderator is basically some light nuclei like deuterium or carbon, with which the neutron collides and loses most of its kinetic energy. Then it goes to the uranium and then it bombards on it, and then three neutrons come from here with, then they do the chain reaction, and on purpose they are slowed down to have a controlled manner of reaction. So it's related to slowing down of neutrons, and I have just made this question very small in here. So here is the neutron which needed to be slowed down by virtue of an elastic collision, because it is believed that in an elastic collision the most of the kinetic energy will be lost. In this case, the neutrons, most of the kinetic energy will be lost. So it need to be slowed down from typical speed 10 to the power 7 meter per second to the 10 to the power 3 meter per second with the help of elastic collision with a moderator, which is basically deuterium, and then it will collide with uranium. So we will consider its initial speed be v1 and its final speed be v1 dash. Okay, so the thing will be, we will just calculate the initial kinetic energy with the help of v1, and then final kinetic with the energy with the help of v1 dash. Then we will find the difference, and we know that what will be the difference. We need to show the difference, that it's most of its kinetic energy which has been lost in the process. So first thing first is, v1 is the initial speed of the neutron and v1 dash is the final speed of a neutron, and which is after the collision with the deuterium atom. So here m1 and m2, let's get this. M1 is the mass of neutron and m2 is the mass of deuterium. And we know that what is deuterium. Deuterium is the second isotope of hydrogen atom, which is like H21. So you denote it with D. So the mass of 2 will be approximately 2 times that of mass of neutron. The kinetic energy initial will be half m1, that is mass of neutron, then v1 square. Then final kinetic energy will be half m1 v1 dash square. What's the value of v1 dash? This is the v1 dash value in case of elastic collision. I may upload this video later on this channel, but we are doing a specific question. What's the value of v1 dash? It's m1 minus m2 divided by m1 plus m2, and square of this, because it's v1 dash square, so we have to square the whole term. Then we can find the change in kinetic energy. That will tell us how much kinetic energy is lost. So initial kinetic energy minus half m1 v1 dash square. Just put down things together. I can just get this half m1 thing common. Okay, we can take the v1 square also common. Then we will get 1 minus m1 minus m2 whole square upon m1 plus m2 whole square. Okay, we have to just wipe it down to get the, okay, just note it down. So it's change in kinetic energy. That means we are calculating the loss in kinetic energy of the neutrons. So it's half m1 v1 square, and this thing will be commoned out and it will become 1 minus m1 minus m2 square upon m1 plus m2 whole square. So we know that m2 is equals to twice of m1. Why? Because this is the mass of neutron and this is the mass of deuterium, and mass of deuterium is of twice the mass of neutron. Okay, so we'll just do it. Half m1 v1 square, then 1 minus m1 minus 2 m2 whole square, then Here it is, m1 plus twice of m2 whole square. This would give us, okay, m1 plus 2m1, what would be? It would be 3m1 whole square, which would be equal to 9m1 square. So 9m1 square minus m1 minus 2m1 would give us m1, and m1 square will be here, and here will be 9m1 square. So we will get half m1v1 square, and the whole thing will become 8m1 square upon 9m1 square. This will be cancelled out, it will be 8 by 9. Okay, 8 by 9 times half m1v1 square. What was that? It was initial kinetic energy multiplied by factor of 8 by 9. That means the loss of kinetic energy is 8 by 9 of the initial kinetic energy. Yani 8 out of 9 part of initial kinetic energy has been lost in this elastic collision, and it has contributed in slowing down the neutron to a very specific extent. Okay, fine. So that was the solution. Okay, the neutron has been slowed down, and the kinetic energy is lost by 8 by 9 of the initial kinetic energy. So here the thing goes.